My God, we're starting to see the inseparability between Tesla and SpaceX. Hardware 3 may end up with a reasonable supervised FSD, but will never go unsupervised. Elon isn't propping up 1 million satellites in space for his health. That is a money-making exercise. At some point, really, Starlink is just a conduit, the intelligence cloud, the AI data center that Tesla will build. He's sort of telling us a story here. From version 1 to version 2.5 to now this version 3.
Did Apple preview the iPhone before they showed it off to the world?
The story of manufacturing on the moon and drop shipping it to Earth is a story that can create vastly cheaper products. The next 5 or 10 years, as long as they have an autonomous vehicle platform, they're going to be improving this model.
Your prediction about there being unsupervised robotaxi at the end of April is more or less likely? Hey, Phil. Welcome back. It's been 2 weeks.
It has, yeah. Wow. 2 weeks.
A lot has happened in the last 2 weeks.
Yeah, like nothing, right?
Like nothing.
Every time we get together, this is our third. It's like 2 weeks. It's like we can't even remember the topics we were talking about. There's so much stuff happening.
I can't even remember what I was thinking about last week.
It's a pretty incredible time for sure. I've never seen things move this quickly. It's kind of crazy.
Yeah. Well, speaking of moving quickly, we've got these two little dudes to represent us, and given that we're seeing some more cybercabs, I thought in honor of that I would doctor this image a little bit and create the cybercab version. Now, for some reason, it seems to think that I should be all gold. I'm not sure why. Am I the golden boy in this pairing?
I don't know why you became all gold. Definitely not matte finish.
No, very shiny. I do like your shirt. I do like the Tesla gold shirt. That should become a thing.
I'd take that shirt for sure.
Yeah.
Yeah, you're totally golded up there. It's awesome.
But from the real thing, we're seeing some more cybercabs. This is from Joe Techmeyer today, and I believe he counted something like 60 cybercabs in various places, and it's kind of nice to see them all in a grouping like this.
Can you believe it? I mean, what was the We Robot event? Was that 2 years ago?
Yeah.
Yeah, October 2 years ago. Look where we are.
Look where we are.
I mean, coming from some set of a car background myself, I'd realize how difficult it is to start with a prototype and end up with a platform and then get to production. And we're very close to start a production.
And not only that, but to develop a whole new production system.
And there's so much. Yeah, this is a multiplier, right? Normally you'd say, I have a manufacturing technique, I'm going to add a new vehicle platform. A new model is easy, right? That's usually just a variant, sometimes just trim. To go to a new platform is significantly harder, 1 to 2 orders of magnitude. You're effectively starting over, but you're probably doing it on your old manufacturing. I mean, you're upgrading some of the processes, obviously, but I think Tesla's done 3 things here that are like extremely substantial. They're going for a new vehicle platform. They're going for an entirely new manufacturing process. And then they're building a vehicle platform that relies on an entirely new technology to drive it autonomously, right? So it's much bigger than just a new vehicle platform. So
we have a guy out there who's making a fearless forecast. You may know him. He's predicting that by the end of April, that robotaxi will be unsupervised in Austin. What do you think about this prediction, Phil?
I know him, and I think he's quite an idiot. Well, I wanted to be bold. I mean, I figured the downside is people yelling at me, and a lot of people are yelling at the clouds anyway on X.
Mm-hmm.
Well, on a serious note, I made a second post about this and saying, like, look, it's a reasonably decent data decision, but it's not, my confidence isn't 100%. But look, I think we're really getting there. The point of this post was to be provocative in the sense that we are going to see that moment where Tesla drops the hammer and they go unsupervised. They run robotaxi proper in Austin. And, we've been waiting for it since June of last year, and we're coming up on a year. And I do think we're very, very close. I see all the things lining up that makes it feel like it's very, very close. I think most of what happened in this 14.3 was telling the story of this as well. So,
yeah, and perhaps you can kind of walk us through this post that you made. You said as 14.3 rolls out, two aspects stand out.
Yeah, this is really cool. I think when we heard about 14.3, I think we heard two things from Elon. It's the reasoning version, and it will be, for all intents and purposes, sentient. Some people say it that way. And the second was it'll have 10x the number of parameters than the previous model. Those are the two standout things, hold Elon to some commitment type of thing. But as we've discussed, and I've discussed endlessly, engineering doesn't work like that. I mean, it may be that people don't like the fact that he puts out some kind of commitment that feels like a firm stake in the ground. But I guarantee that the moment he walks into the next Saturday or Monday night review meeting with the team, whatever is on the roadmap may shift. And Elon has maybe a bad habit of not coming around and reposting and saying, hey, this version will not do this or won't do that. But if you understand that process, if you understand what's happening in the engineering room, it's almost obvious that some of those things that Elon says aren't going to be directly found in that version. What we know about this version is it's taken a long time. And I think that told a backstory that was significant to me. That never told me that it was going to be necessarily at 10x more parameters. That's irrelevant. I mean, yes, it would take longer to train, but not the amount of time since where we're at 14.2.2.5, I think, and we're going to this version. And I think 14.2.2.5 when was that released? Possibly December.
Yeah, I don't recall. It
Maybe
might have been
January?
a little bit later.
Yeah. Well, it is April, and here we are, and let's just call it 3 months, because I don't remember. But what I noted about this was there two what I would say massive things. The first one that I think is less massive is that it is very clear that they have moved from a technique point of view to a lot of reinforcement learning scenarios. And I think that came about because of the ground game that was happening in Austin with robotaxi. Okay, what I think was going on there is, look, here's the thing. Tesla's building this product. They're testing with a number of engineers go out in the afternoon. Let's say before Austin, right? They go out every afternoon. They drive the car for an hour. They take some notes about things. They go back and they say, it didn't go well through this intersection. It didn't do this yield. It didn't do that thing right. It was too aggressive. It was too conservative. It was too this. But that amount of information through a small engineering community is rather small compared to what happened with robotaxi, right? Robotaxi, you've got observers in the Bay Area and Austin pretty much writing notes after every ride. And obviously a lot of them became repetitive, and a lot of those were cured in small point releases along the way. But it's clear that for the first time, Tesla was testing it at scale. So they were running into all sorts of issues. Now, this isn't to say, I'm trying to cure this specific intersection problem in Austin. We're talking about dealing with a lot of specific circumstances where they can collect data from the vehicles, and then when they do a reinforcement learning scenario, they're definitely curing more than one problem. Okay, so it's not like they're just fixing that intersection. This intersection's is 5 ways with a very But no, they're just basically saying, oh, categorically, this is different. We didn't like how the car operated here. Let's go put together an RL. And by the way RL works here is they'll take a piece of data and they'll have a desired scenario. This is what they want the car to do. This is ideal. And then they'll have a bunch of other scenarios that are from really poor, like not ideal, like terrible, to approaching ideal. Mm-hmm. And they'll assign rewards in the model for doing the right thing. So they'll let the car run through a set of what would be called trajectories. And this is all because what's happening here is they can take the original data, the ground data, they can load it up in their simulating framework, their RL framework. It's kind of the same thing. And then they can say, okay, let's run, a dozen different scenarios or 5 dozen different scenarios. And they can put scores on them and they can say, okay, we really want it to behave like this. And so they reinforce the good behavior and then train based on that. So what I think I'm trying to say is it's pretty clear what happened here in 14.3. 14.3 is probably the version that's been running for a bit of time, not 14.3 Golden Master, but 14.3 some build candidate has been running in Austin probably for the last 3 months or 2 months, say. And every time they come up with a scenario that doesn't quite meet their perfect objective, either from safety, comfort, or some other factor, they build this RL scenario and they run it in training. And one thing to note about how they do this is that they're running on an actual AI4 hardware. So there's tons and tons of AI4 hardware boards in the Cortex training center in Texas. So what they're saying in this release is, we've really doubled, tripled, quadrupled down on RL, and we're using that as our primary mechanism to deal with all these edge cases. And they talked about, so I've looked at a lot of the other notes in there and I'm like, well, a lot of them kind of roll up under RL anyway. So this is a big deal, but the least significant, I think, of the two. The second thing that they're doing here is they're basically, so I'll read what they wrote in the release note. It says, rewrote the AI compiler and runtime from the ground up with MLIR, resulting in 20% faster reaction time and improved model iteration speed. I think this is a huge thing. Okay, so what happened here? So just let's kind of lay the framework for this. You train a model, and what you get is the model's architecture, and then you get all the parameters, right? The parameters are just numbers. So the numbers have an organizational structure. They're in layers, and there's a certain number of nodes or neurons, and each of those have biases, and the connections between them have weights. The biases and weights are the parameters of the network. And then based on how that network is arranged, they have different effective mathematical functions for pushing the data through it. I don't want to get specific, but obviously a lot of that ends up as matrix multiply operations that we hear about all the time.
Yep.
But basically, to go from one layer that might be of one type into another layer, here's how the data here's how it has to be computed. Here's the compute, okay? They have the model, when it's represented, is both the kind of architecture of the data structure itself, the layers, how the layers are told to transform as the data runs through it, and then the parameters themselves, which affect the outcomes of the data's computation. And that, when you put that together and you put it on the car and it runs at 36 times a second, it's the runtime. That's and we also would refer to that as inference. What they did was they had a Tesla AI team built up their own runtime, and this is code, right? People to understand this is actual, code written by humans kind of code. Now, it doesn't have to be all written by humans, but This is the data pipeline, how you push data through the system and how you invoke the functions, sometimes on chip and sometimes in code because there's no function in the chip to handle it. We've heard Elon talk about softmax, that he was moving they were moving softmax operation into AI5 as a hardware primitive, as a hardware operation. And just like you might find a matrix multiply operation as part of load up this data set and then just invoke the instruction that says multiply and put the answer over here, right? And that instruction is kind of like at the hardware level inside the chip itself. So what they decided to do is they decided to use a kind of an open source standard, this MLIR, which stands for multi-level intermediate representation, and it's a way to abstractly define that model, not the data, but the model, like what it looks like, how it will, as the data moves through the pipeline, if you will, as the data moves through its inference cycle, how it will, like what compute operations must take place to get it to move its way to the answer, right? So the input is largely vision data and the output is vehicle controls. And in between there's, I'm going to just say 100 layers of of this thing called a neural network. And it could be 50 layers, it could be 25, it could be 200. And there's a certain number of nodes in there. And then as it runs through there are different, people have heard these things like activation and there's just a bunch of different math operations that occur through that. Okay. So they built their own runtime. And I think what they realized is, and I think this is kind of a classic example of they did this very early. They've been massaging that runtime over time to try to optimize it. And I think there was a decision made somewhere in the 14s, meaning like maybe they started this at 14.1 and they said, you know what, we want to rewrite this thing completely, change the runtime out. And we're doing it because sort of like a couple things. We will give us a better way to abstract off of the hardware. And I'm pausing here because when they hear abstract off the hardware, they think that leads to a performance penalty, right? Because you're abstracting, or you're away from it, you're not touching it as cleanly. But the way this framework works, this MLIR, is it allows you to then optimize all those functions. So you're optimizing for two things. You're optimizing for the compute and you're optimizing for the memory load, like how much data has to be loaded and what kind of compute you're doing. And I'm sure what's happening here is as they had this thing running for, the last 2 years through these last big versions, they've been watching the data pump through the pipeline and trying to figure out where is it spending its time? Where is it too memory heavy, and where is it, I don't want to say over computing, but where is it not being efficient? And then they were like looking down on those things and they were trying to optimize that thing. And then they had this better idea, which said, you know what, let's zoom out and replace the entire runtime with something that gives us, I'm sure they tried it and they went, oh my God, look at this. We got 20% performance gain or whatever they advertised. And then and in a sense, now they're future-proofing themselves. They've got a better architecture for how to do the data compute on vehicle, which is super important, right? I mean, this is not like an LLM. An LLM, that process from the user's point of view is asynchronous. It can go off and it can do what it wants to. And we may be upset that it takes 32 seconds, but the difference between 29 and 32 seconds is immaterial to us. On the vehicle, this is a real-time system. Mm-hmm. They require the data to run through those inference cycles 36 times a second or some other number that they've decided is correct. And they do not want to compromise on that. And so one side of it is, go back to the beginning of this conversation. Oh, if we increase the size of the parameters in the network 10x, let's just say on a linear basis, we have 10x more compute. The relationship isn't perfectly linear, but it's close. And we can't afford that on AI4 hardware. We can run it on prototype AI5 hardware, and boom, we can take a 10x parameter model and run it through and still get our 36 times a second, and we're all happy. But try to do that on an AI4. So what the team does is they spend a lot of time optimizing to try to, really, really use that hardware most efficiently, most effectively. And I think this was the big optimization, right? This was the step where they said, let's take a step back, let's spend the time, and let's do it right. And, just so people can get an idea of what's going on here from an engineering point of view, this is the constant tug of war that goes on every single time. You build something, at least from, both hardware and software, frankly. You build something and you wake up on a Monday and you want to throw it out or refactor it. You're basically like, I now know how to do it better. And every day you do something, you know how to do it better if you're a serious engineer. And part of it is that your brain tells you how to do it better because you know what the problem is. You're understanding the nature of the problem you're really trying to solve. It's not abstract anymore. It's quite obvious. And the second is you're watching the data run through, an architecture, and you're trying to figure out, well, why is it slow there? What's going on here? What do we, how can we make this better? And as you go through that process, you are always constantly at the, let's call it the engineering review cycle side, which, let's say Elon runs those meetings once a week or whatever. Let's say it's not just Elon, it's just a shock running those meetings. And you're always like, should I bring up the idea that we should refactor this code or gut this code and start over? Or should I stick with what we got and try to make it work? And so it's not abnormal. Like what I think is, I don't want the takeaway to this conversation being they did it wrong and now they're doing it right. That's not the way to think about this. They don't know what to do right until they did it wrong. It's like you don't really know. And so they got to a place, wherever that was, whatever time that was. Maybe it was in 14.1, maybe it was in 14.2, or maybe they started 14.3 and realized this is what they wanted to really do in 14.3. They took a pause and they said, you know what? Let's just do this. Let's bite the bullet. And that's what they did. So what does it mean? It means it's probably more efficient, and it future-proofs the architecture a bit.
Does it have any implications for hardware 3?
Sort of. I think all of this has implications for hardware 3 in the sense that they really truly understand what compute they need and how to squeeze that compute out of that chip.
Yeah.
So the negative story might be, it informs hardware 3, as in they can't do it on hardware 3. They realize that, they've gotten close with this runtime replacement. They probably got as close as they think they can to being efficient with the hardware, or knowing how to measure it and abstract those moments and, get into that most efficient place. And they may run it on hardware 3 and say, we're just never going to get there. Or, there's something, honestly, if you ask me to place a bet, I'd say hardware 3 may end up with a reasonable supervised FSD, but will never go unsupervised.
Okay.
I would actually put money down on that one. And I would say hardware 4 will most certainly be unsupervised for robotaxi, slightly less clear for unsupervised for you and I.
Okay.
And then AI5, I think, boom, they've got, somewhere between 2x to 10x the headroom to be able to run this stuff.
So Phil, explain what you wrote here about this 10x increase in parameter count and why you don't think it matters as much as people might think.
Okay, well, I mean, For starters, I think I hear a lot of people just talk about it as if it's some kind of magic cure, and most of the people talking about that don't know much about neural networks to begin with. But the other side of that coin, and to give somebody credit for saying that 10x is better than, 10x parameters is better than the alternative, is that we know that we are in the midst of this kind of scaling laws, and we know that the more parameters look, Elon just posted about XAI that he's got, he's building a trillion or a 10 trillion parameter model. He's not doing that.
We'll talk about that a little bit later. Yeah.
Yeah. He's not saying that because he doesn't think that all of that requires more training compute by some, let's say it's linear 10x. So, I think the trade-off here is that they found that it's a much more nuanced cure to problems that they were seeing in FSD could be cured by reinforcement learning, and that this can wait. Mm-hmm. And by the way, I'm not even saying that it's not there, because I don't know. Like, I don't think anyone knows except people that have a Tesla badge. They may have doubled the size of the parameters in the 14, maybe not 10x, but maybe 2x. I mean, Elon always speaks in orders of magnitude, so that's kind of his natural numeric nomenclature, but they may have 1x, 2x, or 3x'd it, as far as I know, right? But I'd say that it's pretty clear what they're telling us here. They're saying that we're trying to chop the tail off, and the best way to chop the tail off of all these crazy nuanced situations is to apply reinforcement learning. And then the second component, which is to get more efficiency. By the way, the whole second part of that conversation about changing out the runtime would be necessary to facilitate this, right? In other words, maybe not necessary, but probabilistically necessary, meaning that maybe they built a prototype model 10x the size and realized that they could never fit it in hardware 4. Mm. It was way off. And remember, they don't have to, train that model and get it down to perfection. They just need to get a model at that sizing so they can run the compute operations through it. They don't have to have good answers. They just have to run the compute through it and say, with this level of these input tensors, in other words, this input camera data, and this output vector, which is the controls, acceleration, steering, braking, can we get 36 times a second with 10x the parameter count? Maybe they found out they could only get 12 times a second on hardware 4, and they said, no way, can't do it. Let's not do it.
Yep.
What else can we do? Oh, let's focus on RL to get all that nuanced stuff done. That's what I think happened, but I just don't know, what I'm not certain of is where did it happen? Did it decrease the throughput from 36 times a second to 12, or was it just down to 34? I don't know. Mm-hmm.
So based on what you've seen so far, 14.3, do you feel like your prediction about there being unsupervised robotaxi at the end of April is more or less likely? And then also perhaps as it relates to Todd's question here, where he says, please address how many more Tesla FSD versions are needed before full autonomy is achieved.
Yeah, exactly 3.
Yeah, right.
Yeah, I mean, it probably, this probably should be said, right? The effectively unsupervised FSD is the same at the neural network layer of what would run on robotaxi as the product as we want it to be, right? That without any supervision, and customer unsupervised. Mm-hmm. But when people say unsupervised, sometimes they just mean customer unsupervised, and they kind of forget about robotaxi because they're just like, oh, wait, we got to get rid of the safety observers, and then over here we want to get unsupervised. Well, people, they're the same thing. At most, at 90%, they're about the same thing. Yeah. In unsupervised, that faces the user, with a customer-owned vehicle, there are some nuances, there are some differences, but at the neural network layer, they're probably the same thing. I suspect that we will get there very rapidly now. In other words, I think it's important to say, get there is not a bright line as the finish line. Nothing else goes beyond that. No, the Tesla will continue to increase, for the next, I don't know, 5 or 10 years, as long as autonomy exists on this, as long as they have an autonomous vehicle platform, they're going to be improving this model. And every single day, they're going to find a use case that they want to cure or fix, to encode. They have a use case that they find that doesn't work ideally, and they want to encode that use case. So, but I think this big leap to 14.3 is the setup for this. Like, it's a setup for, if I were to guess, I would say that 90% of their focus is on robotaxi, 10% of their focus is on worrying about customer unsupervised. Even though they're sort of the same thing, that's not to say that, we're not going to get it or something. It just means that their focus is this new business model of robotaxi. I mean, those cars are telling us that story. They're telling us that they're going there. Those aren't cars for us to buy to drive us home from the airport. They might drive us home from the airport, but through robotaxi, right?
Yeah. Yeah. And by the way, these are, as I mentioned in my post above there, these are engineering test vehicles. They do have steering wheels and pedals in them.
Yeah.
But they're for, engineering test purposes, and they'll be shipped out probably to many cities. And that's consistent with what we've been seeing now over the last few months.
Yeah. So that's an interesting story, because what I think is going on here is that I think you're going to see when they really press the pedal down in Austin and go, effectively unsupervised across the whole fleet, I think we're going to see a lot of cybercabs enter that fray.
Yeah. And
I think that what they're doing now is, kind of in a parallel effort, is that they are cybercab. If you look at a 3D geometry of, say, a Model Y, a Model 3, Model S, a Model X, and a cybercab, and you place the cameras just sort of, they may have the same number of cameras, but they're not in the exact same places, right? They're off by an inch or two here, and that, so Tesla has built into their model an abstraction for that, right? They effectively, the model kind of comes up with a way to abstract the coordinates of the cameras. Now, when I say that, I don't mean like if this is the left quarter panel or whatever this camera is, it's largely doing that, right? It's not like, we put it on the roof and then it's abstracted, but it may be off an inch or two here. And I think the reason that these cars show up, and I think sometimes they show up with those solid state LiDARs attached to the top, is it's largely to calibrate these cars.
Yeah.
And I think that they've, they're running as they get closer to start of production. And the start of production, if they hit that button, in the factory, and they start outputting cybercabs without the steering controls and so forth, they want to make sure that they are calibrated. And so they're not just doing that in Austin, but you can see that they're doing it across a bunch of cities.
Mm-hmm.
The other thing is that while we sit here and think to ourselves, well, they haven't really removed the safety observer, because it's not, in Austin, it's sitting in the passenger seat, right? So in the Bay Area, it's in the driver's seat, but that's for a different reason. Regulatorily speaking, they have to have that person in the actual driver's seat. So there is this moment in time where the fact that I see them spreading the love across many, many cities now, like testing, getting ready, makes me feel that that's why I was sort of more certain in my prediction, because if I see them playing around in San Antonio and Dallas and Phoenix and Miami or wherever wherever they are, that kind of tells me they're really close to just basically, pulling the plug on the safety observer in Austin.
Mm-hmm.
and going for it.
That'll be exciting, because after all, I want my unsupervised FSD. Yeah.
I wonder, does the age of our audience, do they understand the MTV reference?
I think so. I think they would.
Yeah.
Yeah. There may be a few younger folks out there that might not get it, but anybody in our age range would understand.
The other thing that gives me great confidence is FSD is doing all my driving now.
Yeah.
Last night I got into the airport, San Francisco, and I took the crazy. I just didn't do it. I don't know why. I just should have tried it, but I was like, I want to get home, and I don't want to play tester at this moment. So I did the crazy spiral loops out of this parking garage. But the moment I got past the pay, I just, home, go, sat there the whole time, and I pretty much texted the whole ride home.
Mm-hmm.
So, that's what I do all the time.
Yeah. No, it really is amazing. So you mentioned earlier Elon's post here about SpaceX AI Colossus 2 now has 7 models in training. And we're talking about some big models here, right? Up to 10 trillion parameters. Explain to us what he's talking about here, Phil.
This is awesome. I mean, well, what he's telling us, what you remember, if we go back in time, and it's not that long ago, honestly, Elon had boots in the ground himself in Memphis at Colossus, and late night meetings. We have pictures of him standing in the parking lot, and what was he doing? They were, figuring out the way. They were speed running the build out of one of the largest data centers in the world, right? And they found some workarounds to get it powered and equipped with the GPUs they needed. And why were they doing that? Well, now we know. I mean, we kind of knew, but what Elon is doing here is he is trying to beat them all. He's willing to go for it. I think he said that he may not beat Google in the West, if you recall his post, but I don't think he thinks that he's not going to lap Anthropic and OpenAI and anybody else out there playing on the frontier model side. And so what he's saying here is, well, one of the things that he said for the last 2 weeks is, and this is a great topic that could go on forever, is, and we talked about it a little bit last time, is vision-based AIs and language-based AIs, and the kind of over time, which one got more traction and some got more effort. And vision was a big thing before LLMs, and then LLMs became the thing that gave us a sense of knowledge. Elon said recently, guess what? I'm not backing off at all on what I'm doing with this Imagine, which is essentially a pixel generator. And he made some comments on whether it's revenue generating or neutral. I didn't understand, nor did I care what he meant by that. But he's saying, I recognize that to get to AGI, that vision input and output are very, very important. Mm-hmm. And so I'm not backing off. So, we're dedicating a lot of our compute towards this thing that some people look at and go, well, that's just folly because it's just generating, it's just animating my dog, or and I don't think that's what's going on in his brain at all. It's the precursor to a lot of stuff that I think will happen with Optimus in terms of its vision stack. And then on these other ones where he says two variants, they are moving their more traditional frontier models, the LLMs, to much larger models, right? What did he say here? Yeah, Grok 4.2 is a 500 billion parameter model, and he's looking at building 2 variants of 1 trillion. So first part of this is he scaled the hell out of Colossus so he could even do this.
Yeah.
What's the limiting factor? Well, I need compute. I need energy and compute. Okay. Having got to a happy place, now he can take that data center and he can do these things in parallel. And so what he's really saying here, independent of the numbers, is I'm doing a lot of shit in parallel there. Amazing. And that is a way of saying I know how to speed run this process because I have enough compute. I've set aside enough compute so that I can parallelize the problem of, and I can test out, like, what's two variants? Well, training it one way. I don't know what it is, but they're training it one way for one variant, training it another way, and then they're going to get to a happy place. What I mean by that is the model won't be every epoch run through and everything will not be computed. They'll get to some place where they go, it's good enough, and they'll try variant 1 and they'll try variant 2 and they'll go, variant 1 is superior. Let's stick with that. It's a bit of, trial and error.
So why even bother with the 1 trillion if you're doing 1.5 trillion parameters?
For the same reason, I think, which is they may find out that the 1 trillion variant 1 performs better than both variants of the 1.5, or the 1.5 trillion parameter also has different data sets, or the architecture itself of the neural net is different.
Yeah.
So in other words, to say 2 variants almost implies that either the data they're running through is different, or the network architecture, the neural network architecture is different, or both, to get 2 different variants. And because they both have one thing in common, 1 trillion parameters, right? When you think about AI in the sense, it's like a mathematical function, right? You have input, goes through this funny box of numbers, and you get an output. And you hope to get, for your input, you hope to get a great output, right? Whether it's driving or answering a question. But the reality is that you don't have a lot, like if you're writing a function, a mathematical function as a person writing code 5 years ago, or whatever, you build this function, you build a set of inputs, you look at the outputs, and you say the function does what it's supposed to do, or it doesn't, right? You have a bunch of test cases, and you might complain, oh, it's running too slow, so you make some changes. Then you find out, oh, it doesn't, all the inputs don't work, or something like that. But AI is so much more nuanced. It's just sort of like 1 trillion numbers. And if any one number is slightly different than another number, you wouldn't notice it. But if it's in the wrong place with the wrong number, it might give you the wrong answer. Part of this process is that they have to train with enough data, a lot more data, but a bigger model, in some sense, is a better nuanced mathematical function. And it's also a bit more impervious to a couple things being wrong. Like one number's off in 1 trillion versus a 0.5 trillion, and it's a lot easier to settle that you get an okay answer on that one.
Does training a 6 trillion parameter model take 4 times as long as training a 1.5 trillion parameter model?
Invariably, the answer is no, because they never do it the same way. In other words, like the second they decide to do a 10 trillion parameter model, they also decide that they want to put more data through it, or they want to change its interior architecture in a certain particular way. So, in other words, that they're not, from an apples to apples point of view, it's reasonably linear, but it's never that way, because they're not trying to build an apples to apples comparison. They can do that in a lab. They don't have to do that in an actual training. But they're going to say, oh, when we make this 2 trillion parameter model versus this 1 trillion, we're going to add a couple more layers. We're going to make it, most of these bigger models like this are mixture of experts models, so that when you're running data through it, only part of the model lights up, whereas you don't, when you hear trillion parameter model, couple things should come to mind is, oh, it's going to take longer to build it. Yeah, it's going to take a lot longer to train that model, if apples to apples. You might think, oh, well, then therefore it's also going to take, twice as x to 2x, or whatever the start was, 0.5 trillion to 1 trillion, to compute through that model. Maybe. It depends on how you organize the interior. So if you build these mixture of experts, you may say, well, taken the math expert and we've broken up into these little sections over here. They're better trained to do these kind of math functions for this mixture of experts component, versus a generalized math one. So, you end up with, there's a whole conversation going for quite some time on how you take a model and then you make it efficient to run through inference, because these models, if you just do a straight compute, the amount of memory they would need to load if you did no optimization would be almost implausible, like impossible to compute the model. So clearly, these models are componentized through this mixture of experts technique, as well as some other overarching things like quantization that changes the sizing. Because a model is a bunch of parameters, a bunch of numbers, right? So in order to compute through a model, if you had to go through the whole model, you have to load that whole thing in memory. Well, where's that memory? If you think about it, and if it's too big, it doesn't fit. So now you've got to go, well, how am I going to make it fit? Well, you can say, well, over here on this side of the data center, we run these experts in our mixture of experts, and there's, this is the math thing, and this is I'm making these up, but this is the Italian to English expert, this is the physics expert, et cetera. Mm-hmm. And so you can, that's why you see, if you're using Grok 4.2.0, you see these different agents go off. Well, I guarantee all the agents aren't going to the same place. I mean, they're not doing the exact same tasks. They're, some are going through this side, and then there's a coordinating agent that comes back and gets, there's a coordinating agent that dispatches the sub-agents, says, go off and do this thing for me and come back and check this and check that. And then he comes back and they all give the data, and they may sub it out again, or he may collect it and come up with a final answer. There's a lot going on here. So
is going from a trillion parameter model to 1.5 trillion, is that kind of like, you bake a cake, you learn from your mistakes, so the next time you bake it, you're that much better, but you don't actually use the cake in baking the next one, right? That the cake that you've baked is trashed. You've just taken your learnings. Is it like that, or is it?
There's a good chance that when he says two variants, that at least, so there you got 4 models there. There's a good chance that only one of them shows up as the baked cake that you sell to the customer, and the rest just get trashed because haven't met the threshold that they're looking for.
And you can't take a piece of one cake and add it to the other cake and end up with a better cake.
Not particularly.
Yeah.
No, not that I know of. I mean, there might be something. It may be that they, in a sort of a mixture of experts architectures, let's say variant 1 with the 1 trillion is good at math, and they're like, okay, we'll use the math component of that one and we'll let that go live, and then we'll use over here, this is the general one, and then we'll talk to this math one. I really don't know.
You made 2 points. Would you like to elaborate on these a little bit?
Well, it kind of will confuse the folks to say bigger is better. Scaling laws. What I think we've learned in AI, what the better lessons about, what a bunch of things are about, is that more compute is better, and theoretically larger parameter models are better. Now that is a little bit in conflict with our FSD story earlier, but that's why I said theoretically. Again, it only matters when you use it and goes through a bunch of test cases, and you find out that, well, it was 2% better with 10x the size, probably not worth it.
Yep.
At least in case of what they're doing here at XAI, they are basically saying out loud, we're adhering to these. We built for, we understand, we're adhering to. We supersized Colossus for the idea of scaling these models. And that's what we're doing. And then the second thing he mentioned was, as missing important training data. And that's a really interesting comment, because, we don't know what it's missing, and they aren't necessarily going to tell us, but it could be missing, reams and reams of textual data, maybe, all the PhD theses from biology are missing. I don't know, but some set of data is missing, so that they're basically saying, guess what? We're adding missing data, which circles back to our previous point here, which is, okay, go ahead and add the missing data. Well, that's going to guarantee that you're going to end up doing more compute to build the model, right? So there's this kind of tension, I guess you would say, is well, I guess the easiest way to say it is all n parameter models are not equal. They can be architecturally different, and they can be different in terms of how they're trained from a data input side. If you just trained, you could build a trillion parameter model with just an encyclopedia set and end up with a very limited data set, right?
Yeah.
For example, if that encyclopedia set was last published in 1980, you would never have anything. Remember early days. I think it's less of a problem, but you would go to OpenAI and you would try the latest model, and it would tell you whatever my answer is, it's a year old,
right?
Because
that was frustrating.
Yeah. Now models work differently. You can see, even with particularly the XAI models, is they reference current data and they bring it as context data and they shove it through, so that they're not. Yeah. So like XAI, you can ask it like, what did that idiot Phil Beisel say in the last 24 hours on X? Can you summarize? And it will do that because it has access to that live source. It's not trained in the model. It's actually reaching out to the source and getting the data and shoving it through the context window. It's part of the prompt. It's effectively part of the prompt.
Yes. Yeah. Well, so let's shift gears a little bit and talk about a couple things that I talked about this week. And maybe you can, I'm interested in your reaction, I guess, to some of this. I wrote an article, and I sort of teased this idea of Tesla's next new product, although, it's kind of already there and it's pretty obvious. And I'm calling it a persistent computer, but I think there's so many different ways of describing this. And the idea behind this is that, we think of Tesla as all these different products, services, right? A car, a Megapack, a Powerwall, Optimus, an AI chip, a data center. But when I begin to look at this, to me, they're building computers in every place that matters. And of course, the purpose is not to build a computer. The purpose is to have the computer in the place that matters to do the stuff you want to have done.
Yeah.
Right. So I'm a little bit backwards in how I'm describing this. But if you think about, the vehicles, they're computers on wheels. If you think about Optimus, they're computers that walk. If you think about, AI data centers in orbit, then these computers have wings, so to speak, right? And so, some of them are large, megapacks, massive, Cortex and Colossus, massive data centers, very large intelligence factories. And then sort of, if you look at it from this perspective, the thing that's kind of missing is then the small computer that just sits there in your home.
Mm-hmm. Yeah.
Also, the small computer that sits there at a supercharger site. And Elon's already talked about this in terms of having inference computers there. So this isn't, this wild and crazy idea. I think this is certainly coming. Whether or not they will actually develop a, like a Mac Mini type product that we can buy from Tesla, I think remains to be seen.
Right.
But as you pointed out, that it would certainly make sense to combine this with Powerwall, combine it with perhaps the charging device on your wall in your home, or perhaps even Starlink and the Starlink terminals. There's so many different places that you could put an inference chip.
Yeah, including just your car too, right? I mean,
yeah.
I mean, I think this is a very provocative post in several different ways that aren't as direct as you put it. And I think that was your intention in a way. I mean, what one sort of macro on this is, my God, we're starting to see the inseparability between Tesla and SpaceX. because to me, not only are we saying here, or you're saying here, we would like to multi-size compute and purpose, some of it is based on purpose and place. Like, where are you putting your token factories? Well, you're putting them inside the humanoid because that thing needs to produce tokens to actually do its thing. But if you think about discussions about macro hard, right? And Elon alluded to this. Essentially, not only did he say, we could do, we could do distributed compute at supercharger sites, but we could do it in your home on your Tesla vehicles. And it brought up the obvious question, well, maybe we need a little Mac Mini that's an Elon version of a Mac Mini that does the stuff. But I was thinking that, if you think about it at this macro, it's like, what is SpaceX and Tesla solving for? They're solving for intelligent compute practically anywhere, intelligence compute, obviously driven by purpose to a certain extent, energy and network. And to me, if I just assume energy is just the required entity, a component, I kind of think about the network and the intelligence stuff as sort of a single thing. Like, I think we should, while we will think of using a Starlink to connect our devices to the internet, as we, at some point, really Starlink is just a conduit to the cloud, to the intelligence cloud, that the AI data center that Tesla will build, and that there'll be really no distinction. We'll be using services on our devices that will just use Starlink to get to intelligence compute. And so maybe that obviates the need for local compute, or maybe it doesn't. And if done right, the reality of this is, when you apply network and you apply compute, you essentially end up with this sort of homogeneous intelligence layer. In other words, if you had an Optimus in your home, it could do compute. But if you didn't buy an Optimus, maybe you have to buy one of these little compute devices to do the compute. But maybe if you have a car, you don't need the other two. But maybe if you have the two of them, or maybe an Optimus in your home is used by your neighbor, or it's used by the fleet as a whole to do some larger, data gathering and compute exercises that we've discussed at other times. So, Elon's really lining up all these points of convergence between energy, compute, and network.
It seems like part of this, Phil, is solving the near-term problems. Certainly orbital data centers are coming, and we understand what that will bring us, or at least we understand partly at least what that will bring us. But in the meantime, you kind of have to go where the energy sources are. And this is why, again, going to the superchargers is great, because that's already in place. It's already set up. You don't need additional permitting. You just use it. And same thing in your home.
Exactly. So, I mean, the point there is that if you take, it's not just total energy to compute that is the problem. It is where that energy is, where that compute is located relative to that energy source. Yeah. So if you want to do a terawatt of compute and you try to do it at one data center, good luck with that, because you need to really probably do all your 90% of your power would have to be behind the meter. And by the way, a terawatt's insane, because the United States is about half a terawatt of consumption. But what you're making an argument for, which is sort of what I'm saying, is it is a distributed problem. It is a problem that allows, if done right, you can build a compute fabric that is distributed, and it is where the energy lies, if you will. And that inherently means that network is part of it, because without network, you can't coordinate effort across, in other words, you wouldn't decide, oh, geez, let's go train one of these big models, at thousands of people's homes. Probably not, because that requires some kind of what they call coherency of the, it's like we're trying to build a single supercomputer that kind of operates together in these data epochs to train. But inference is by far the largest part. It's our use of AI is, 99% or will be close to 100% of the material use of AI, compute of AI. And that leads itself or lends itself to distributed inference, and to your point, either on device where it makes sense. But I mean, we could end up with a circumstance, for example, like you could buy maybe a couple of these compute cores to put in your house so that your Optimus is much more effective.
Yeah.
Whatever that means. Like, in other words, it can do more effective intellectual tasks, generate more intelligence. Maybe that's required. Maybe it's not, I don't know. But what does that require? If you put 5 of these nodes in your house and you've got 20 at your neighbors and 150 at your supercharger down the street, and you've got your Optimus here, and you want to work it as a whole, it requires incredible network.
Yes.
Which is somewhat the domain of SpaceX these days.
Mm-hmm. The other thing too is, we talked about this, I think, in our last show, this idea that, we're building intelligence that's going to be surrounding us. Like right now, if we want to access intelligence, we have to sit down at the device and we have to query it.
Yeah.
And we're seeing the development of agents that can go out and do work themselves and come back and report to you. But you're still in this loop. You're directing it. You're instructing it. It requires quite a bit of input and effort on the human's part. And when we get to the situation where all this intelligence surrounds us, we've talked about how many things will just kind of magically happen because they can be automatically coordinated within the system because all the pieces are there. Mm-hmm. I just wonder if you have any additional thoughts on all that.
Well, I mean, that's what we kind of mean when we say agentic, because what we're trying to say is, when we think of a task, we think of, if I ask you a question, you respond, it's largely me making a synchronous request to you. I'm making the request, you're responding, I'm waiting for your answer. But I could equally say to you, Cern, can you go off and think about this problem? And then I go off and do something else.
Yep.
And then tomorrow we get together and you say, yeah, I've given it a lot of thought. And in fact, I asked a bunch of other people too in the process. And they asked a bunch of other people for all we know, maybe disclosed, not disclosed. And so what we have is this big framework of it's like the task gets separated from the time. Mm-hmm. And we end up with agentic kind of processes that are inherently asynchronous to our request, and they can go off and do what they need to do. And that's why we often say things like, well, what is distributed compute? Could someone use my FSD computer while it's, in my home? Well, of course, as long as it's well networked together, and there's a coordinating framework that can, ask it. And yeah, so I think what this leads to is if we watch these companies, Tesla, SpaceX, build this compute fabric, like that word, makes me sound more technical, doesn't it?
Fabric of space and time.
Yeah. But if these companies build this fabric, then you end up with what you think of as just some intelligence out there. You stop thinking about local nature of compute, and we've talked about the idea that devices like this, our so-called iPhones of the future, will be doing some of the compute local, but we always ask, well, how big? Somebody asked me, how big is the neural processor on here compared to an AI5 chip? And I'm like, oh, it's puny. Because this thing maximum can draw like 5 watts without taking the battery to zero.
Yeah.
Whereas that thing's running at 250 watts. And so just from a compute point of view, you can see it's quite a bigger. So you can't jam an AI5 chip in this thing and make it go. Mm-hmm. But if you have a great network that has low latency,
Yep.
You can certainly ask this thing to do something that can use that AI5 chip in your home or in your car or in your Optimus or at a data center or at a supercharger, right? And then this device becomes nothing really but a thin client. That's a word that people used years ago, thin client, where it's not so much compute bound, or compute centric. And therefore, you could imagine Tesla say, well, Tesla can never build a device like this because they're not optimizing for low power devices. And I'd say, well, that's crap, because what they would be optimizing for is incredible network connect to Starlink. That would be connecting to a next level up intelligence layer known as the data center in the sky that SpaceX will build. And then what we do on this thing will, because we have very low latency, meaning like the request to response is tight enough that we would think whatever we're doing on this device feels like it's all happening on the device. It allows you to, that's another reason you need to distribute compute, probably because of, that's a different form of energy density problem. It's not like, it's also because you don't have enough energy or you can't consume enough, but that's because we physically can't put a battery in these things yet. Battery tech isn't like, following Moore's law, right?
Yeah.
So we're not getting the same compute on device that we could get in, incrementally over time.
It's interesting too, when I think about this persistent computing or this intelligence that surrounds us, here's a couple of silly examples, but I think, if we really think about it, we can probably come up with some better ones. But think about, you're doing some work in your house and you need something, you're putting something on the wall and you're missing the right piece of, hardware that you need. And so what you have to do today is either make a trip to the hardware store yourself, or you stop what you're doing, you look on Amazon and you order it on Amazon and you have it delivered, maybe tomorrow.
Right.
If you have computing device, and ideally Optimus, who can just observe you, or Optimus figures this out for itself, what's missing, and then places the order and makes sure that if it's arriving, it goes out to the curb and goes and gets it and brings it back to you. It's taking the human out of the loop in so many of the different steps that we have to do today. Or if you think about maybe getting ready for going out to dinner, there's some variability in when you leave. And when do you order the robotaxi? Is it 15 minutes before so that you make sure it arrives on time? Or can Optimus or something in your home observe your actual progression towards getting out the door? Oh, Phil's putting his shoes on. Maybe now we should order the cybercab.
Yeah.
But there's a certain amount, I think, of anticipation that could happen here with this persistent computing that we can't achieve today. One of my great frustrations is I've got to stop what I'm doing, get on my phone and do something, query it, place an order, make a reservation. None of this is really all that seamless.
Yeah, so you're talking about, it's like kind of this idea of, it sort of goes back to agentic to a certain extent, but it's like service intelligence layer. Mm-hmm. Like, what we're talking about here is, to use another silly, making me sound more important than I am kind of phrase, is like we're bathed in compute intelligence, right? It's all around us and it's observing us and it's helping us and sometimes for trivial things and sometimes in much more meaningful, bigger things. But it's kind of like today we have these devices in our house, like Amazon Echo or what I think it's, is that what it's called? Echo? Alexa, the Alexa products.
Yep. What's the device called? I'm not sure. Yep.
We're getting to a place, those are, we'll call it very, very first generation products. And, they don't do very much. They don't do it very well. And they make a lot of mistakes, especially like the Siri products. But that'll all change. Especially I think Optimus really starts to, let's put it this way. The expectation of Optimus is to change that equation more dramatically so it becomes a very effective and physically effective. That's the other element, right? Because that's what Optimus gives us, is this sort of physicality, this embodied AI that can not only service our requests, much like the product category I just mentioned in the next dimension, next generation, I should say, but also like it can do things, so it could, I don't want to say go to Home Depot for you, but it could certainly organize the order. Some cybercab shows up, it can go out, pick up the thing in the trunk and bring it into the house and say, okay, here it is. And that was a 20-minute wait versus, you making the 2-trip required.
Or there's no reason that Optimus can't look at my refrigerator every day and order the necessary items that are low or missing.
Or just observe what's coming in the house, or actually be the one that does all the shopping. And when I say that, I don't necessarily mean like gets in your car and drives to the supermarket, but I mean like uses this intelligence framework and says, well, I need these things delivered. And your refrigerator gets full. Optimus is walking in groceries. It is getting it from some cybercab that showed up. You didn't pay much attention to that. All you simply said is, Optimus may say, do you want eggs for breakfast tomorrow? Yeah, I guess. Sure. Well, at least I might want to. Okay, great. Well,
yeah. It becomes a bit like a luxury hotel experience in your house.
Well, we know a little bit about human nature, but I wonder about how humankind will change with relation to these very, Optimus will really explode the utility, right? Because of its physical embodiment, the utility value goes up, 1,000-fold, because it can't, it doesn't just have to respond to you, but it can do the things you want it to do. So, what will it take care of grandma? Will it take care of your baby? Will it be responsible for all diaper changes? Does it feed and walk the dog? Everybody wants their dog walked, but they hire dog walking services half the time.
Right. Lastly, on this particular topic, I took the liberty of taking this image that was from the master plan part 4, and I've added a few items courtesy of Gemini. And so I added the stationary compute nodes. I called them AI5 X1 and AI5 X10. The X10 one's here in the supercharger, kind of the lower right, and the AIX1 is on the home. So the idea here is that you're combining the devices that perhaps are already present wherever the energy source is. Then that becomes compute, an inference node essentially, in the vehicles, in the bot, in the house, at the supercharger, in the semi, in the factory, in the megapacks. All these things it's an opportunity to kind of serve two purposes now, which is really quite interesting to think about. Really, everything can serve two purposes. The car can move people. The car can also be an inference tool.
Right.
The bot can do actions. It can also be an inference tool. It can coordinate with different things. It's quite an exciting future to think about. And of course, there's also the space aspect of this, which is not pictured here.
Well, it's again, it comes back to a bit of think about where your electrons are versus your compute need, and note that what's between them is probably a well-oiled network.
Yep.
You don't think about it. We don't think about the internet as much as we were worried years ago is this office LAN connected to that office LAN. Isn't that a crazy thought? Like nobody thinks about those thoughts anymore. Nobody thinks
get very
about
upset now when the internet doesn't work and we realize how much we rely on it.
Yeah, it's as good. It's as much as a necessary utility as running water to our home. At least, not necessarily Darwinistically so, but we miss it right away.
Yep.
I got on a United plane last night, and it was a 4-hour flight from Nashville to San Francisco, and I was really feeling the pain of not being on the network. And I was like, I wanted to catch up on a bunch of stuff that you and I have been talking about. I was like, well, I got to kind of actually download them. And we don't have Starlink on this plane. I mean, there'll be a moment where that'll be present everywhere, and we'll be like, wow, we don't think of getting on a plane as we need to. I mean, like all these things, like you get Netflix, you can download a show, so you can. And I'm sitting in the downloading some podcasts, so I can make sure that I have them available for offline. But the other thing is, like, it sort of comes back to this conversation about energy distribution, compute. How much do you have? How much do you need? And with that network layer, the only issue you have to reach to compute is latency, right? That's the only issue you have. So if your task is inherently asynchronous, if it inherently can be delayed to response, you're pretty much clean to compute anywhere on Earth, or frankly, in at least Elon's version of first gen, data center in space. Not when we put a huge compute cluster on Mars, that's not going to work for us. But that kind of latency, where you're talking about in the millisecond range, allows us to interact with those things as if they're part of the thing itself. And since we have these constraints, like if we take Optimus and we think about, like I've always told people that the last 2 months of the Optimus project will be the engineers optimizing compute for battery. Because they'll say, oh my God, in these 5 use cases, we put this thing out there, it's only going to run for 1 hour before it needs to recharge. And by the way, I'm making that up, so don't everybody freak out about it, because I don't know. But I will tell you, at the end of any of those projects, that is exactly where those engineers are spending their time, because you've got a relatively small battery, maybe 2.5 kilowatt hours of energy on 2.25 on Optimus. You've got this beautiful AI5 or AI6 eventually, whatever chip that can go 250 watts. You've got all these actuators that want to, move around and do stuff. And when you start to factor that all in, you're like, well, maybe I do need to do the intelligence stuff off bot and focus the bot on the physical, like physical motors, and push some of the intelligence requests off to another compute node somewhere else, as per your diagram here. That's what I see ultimately. I mean, like when you use Starlink today, you don't think about how many satellites might be involved in your connection, and usually it can be 1, or it can be n, where n is a small number, but it's because they're, I got to make the request, but I don't have a ground station here, so I've got to go 200 miles this way by laser link to another Starlink who can ground station it down. And you don't think about that. You don't even have any sense of where's my data going. Even with terrestrial networks, whether they're optical, or you don't know where your data is going. You don't care. And it's funny how years ago you cared, because it was very much in your face. It wasn't abstracted. And today I think we're at the same place with compute. It's not yet abstracted. So that's what I'm trying to say, is like network is sort of a layer that's become abstracted to us. We think of it as like the running water. We don't really think about where's our water coming from. We just notice if it's not on.
Yep.
And it could come from different sources, and it come from different pipes. And it could be one day this dam is providing water, and then they shut it off and because of repairs, and then it comes from some other place. And maybe we taste a difference in the water if the city multi-sources the water. But network is sort of like, we don't think of it. We think of it like that now, right? We're not there on compute.
Yeah.
And I think we'll get there. And by the way, in order to get there on compute, we need that network side. So we will get there on compute, and we will stop thinking about, I need to buy a computer to do X because compute will just be sort of around us.
That's a good segue into kind of the next thing that I wrote about this week. This idea of a new market for intelligence.
Oh, the article I didn't read, by the way.
Okay,
Sorry.
well, this will get your fresh take on it then here. So let me just kind of walk you through this, and this is no, great genius on my part, but I think it's worth thinking about in terms of the implications of this, because intelligence is going to become a type of commodity. Right now, intelligence is not a commodity; it's in everybody's brains uniquely. But with AI, intelligence is just going to be a commodity that can be moved around, traded, and so on.
Right.
And so whenever you have a new commodity, you also create the opportunity for arbitrage. Right? If you think about arbitraging the price of oil in different markets,
right,
you can do that because the cost of production in different markets is different, and the cost of storage and pipeline transportation is different. And it allows people to arbitrage that if they have the ability to shift that product from one location to another. And so I just kind of followed that thread in this piece. Again, when something carries different prices in different places at different times and in different forms. So you think about, energy traders trying to arbitrage the cost of energy in different markets, whether it's oil, whether it's electricity. Mm-hmm. In some places that's possible, in other places it's not. And the whole reason that we have, global supply chains is because production costs vary by different regions of the world.
Right.
And there's an advantage to building something in one location. And then, of course, the supply chain has to react when there's tariffs, because now that advantage has been eroded in some way, and you've got to constantly adjust. And this is something that markets are used to doing. So it's interesting because, as I mentioned, for most of human history, intelligence was trapped in our brains, and AI is completely changing that.
And when you say that, it's important to say specialized.
Yes.
Right. So like what you know in your brain about things are not what I know. So you have to go to the Cern to get that answer. You can't go to Phil to get that answer.
Right.
You'll get a poor answer. Yeah.
Yep. Yeah. Good point. And of course, now it's going to be, intelligence is going to be essentially in the future beamed down from space, from above. So here's something I wanted to get your take on. So when you have this intelligence that has three dimensions, right? Time, location, and capability. There's this new layer in the economy, and I call it this intelligence routing layer. And it needs to function like the internet routes data, or the way that power grids route electricity. Mm-hmm. So it needs to determine in real time where these tasks will be executed. And you were talking about this previously in this conversation, when they should be executed, and what type of intelligence it should be used. A 10 trillion parameter model, or one that's much smaller. Is that sufficient enough? Or, a mixture of experts in this fashion versus the other fashion. So it seems to me that this too is kind of an important part. And I guess my question to you is kind of, where are we in this today in terms of building this intelligence routing layer? Is this going to be potentially a difficult problem or an easy one?
Oh, it's a really good question. I mean, and I know what I'm about to say is, I know there's a lot that I can't say because I know it's sitting over here in some, like I haven't read much on this, but, one way, like there's two extremes here, right? One extreme is all intelligence nodes are equal, it's homogeneous, and the routing problem is just availability. It's just literally like, find a node that can do my compute for me. The other extreme is, no, these nodes, much like a human, are clustered in a fleet of nodes, or a grouping of nodes that have a certain knowledge set. And today, when we think of routing intelligence like Grok 4.2, we think of this like master agent that subs it out to these other agents, but we don't generally see or think of XAI calling over to Gemini and asking it something that it would know, that Gemini knows, that it doesn't know.
Yeah.
I can't come up with perfect examples of where that intelligence may be specialized. But if we assume it to be true, as opposed to if we assume it to be true, yeah, we don't yet have, and there's probably someone who's written on this and has some, it's probably a lot of, like, it's probably someone listening to this right now going, you idiot. There's this whole thing out there called, that happens to me a lot, so I don't feel that bad. But yeah, you need this sort of router, because today, I mean, like, if you look at an internet today, you know, when we go to a different website, why do we go to one website versus another? Because there's different data on different websites, right? Mm-hmm. And for the most part, we're making that conscious decision because we know that website A has what we're looking for. And if we can't find it there, we look in website B. And if we can't find it there at all, we just go to Google, or at least let's go pre-LLM days, and we go to Google. And do we ever think of Google as sort of an intelligence router? In a sense, it is, in a weird kind of not so awesome sense, because it still makes the human do the heavy lifting. But what it does do is it presents at least options to you. And I think that as we go down this road further with these LMs, I mean, let's just call it intelligence. Let's forget about LM, the word LM. It would make a lot of sense that different specialized AIs could participate. It's sort of like that mixture of experts thing we were talking about earlier. Mm-hmm. We know those architectures exist. They're just never presented as cross-company today. Like, they're just considered as, XAI does this model. It's called Grok 4.2. It, runs out 4 agents. They converse with different of MOE, mixture of expert models. They gather back the data. The other part of that is that the data comes back and it's organized, right? It's not just it doesn't just come back in a bunch of separate blobs and forces the human to connect the dots. It goes to the routing agent, which is what it does. It goes to the original, the master agent, and the master agent takes the results back and it builds a cogent response and sends it back to the human. This certainly, when we think about this, it's largely comes back to kind of a network problem. And I'm sure the people who have, if there's writings on this, it's probably a lot of people who've come from the networking world, because
this is kind of a Cisco systems of the AI world.
Yeah, if you look at today, if you look at routing, it's that there's a layer cake of networking protocols. Layer, I don't know if they start with 0 and it goes up to layer 7. Application layer down to physical layer of networking, and each of them have, and when you're routing data across the backbone of the internet, you're doing it pretty much at the lowest level of these layers. You're getting off your Wi-Fi to your routing point at your ISP, and then it's really happening at that routing is happening at what would be, I don't know if it's layer 1 or 2, because I forgot my layers, but it's happening at the what's called IP layer of mm-hmm. TCP/IP. Who cares what, but it's happening at the IP layer. That's pretty low. It's not at the physical layer. It's a bit above it. It's the logical network layer. And that's where all the basic stuff in routing is happening today. And to formalize it as something that would be a generic intelligence router is a really novel and interesting thought that either people have given great thought to, or it's just a novel and interesting thought that either is required or may not be required. But it's certainly something that can occur. And I think the way to think about that may be more about cost-based as opposed to
right. It's an optimization that has to happen.
Yeah. So if you have this may be true. I mean, there may be stuff already in agentic AI frameworks. There may be, in other words, what we're talking about here is the difference between someone building a proprietary solution and someone coming up with a generic, sort of like the TCP IP of intelligence, where it's just generic and it becomes adopted as a standard and everyone starts to use it. And either that thing exists and I'm just ignorant of it, very possible, or it doesn't. It's been more theoretically thought of and written about, and it may be more relevant to the cost of compute than.
Yeah.
We talked about we've talked about this in network systems for years about quality of service and different types of, and you could imagine that if you wanted to pay for compute to get intelligence back. I mean, you're always going to be paying for compute at some level to get, like, Elon isn't propping up 1 million satellites in space for his health. That is a money-making exercise. And what will that compute layer be, a proprietary compute layer? Or will it be a general intelligence layer that is homogenized across lots of different providers that can provide you the same sort of services back? I don't know where that goes.
Yeah.
I think in the beginning, normally what happens is, in anything that's standards based, you have people that develop these sort of protocols or standards, and they sometimes get adoption and sometimes they languish because they're built by committee and they're not solving a specific problem that anybody really has, and they're more theoretical, or because they're built by committee, they're heavyweight and difficult to use. I mean, a good example is Bluetooth. Bluetooth is a nightmare of a stack, protocol stack, but it's kind of got some escape velocity, and enough of the world uses it, regardless of how awful it is. But sometimes the way these things develop is a company produces the right tool, the right API, and it gets, great adoption. So if you build a distributed intelligence environment at XAI, maybe the way you act upon that and get at it and pay for it becomes universally,
I wonder, Phil, if perhaps AutoBidder is the early stages of something like this. Because if you think about what AutoBidder does for the Megapack, my understanding is that it's optimizing between, certainly the time of discharge of that Megapack versus charging, and trying to predict things like usage and weather and all kinds of factors about trying to optimize the price. You could sort of take the opposite approach and say, well, okay, what we're trying to do here with this intelligence routing layer is optimize for cost and efficiency. And I've got all these different capabilities and different locations at my disposal with different demands on them. Do you think AutoBidder could potentially be the foundation for something like this?
I don't know. I just have this feeling, this like nagging feeling, because I didn't do my homework here, that if I start to look at this, there's something under well understood and under someone's purview of development that says, oh yeah, we're handling this, or Anthropic has done something that is being utilized across multiple vendors now. So I don't know the answer. I just literally say I don't know. I mean, there's really, maybe a couple criteria that we have to route for. We have to route for intelligence specialization, if that ends up being a thing. We have to route for availability of compute
and urgency of need,
and we have to route for cost, right?
And urgency, I guess, right?
Well, yeah, I mean, I think, yeah, cost and availability are kind of, I mean, there aren't separate things. That it's just like, okay, if I want, it's sort of like, in the, it's going to sound goofy, in the prehistoric data center days, at Amazon, just so many years ago, we spent a lot of time deciding what AWS EC cluster we wanted. I think it's called EC compute. Like no, it's not actually. Wasn't. It's like a compute node. We'd say, oh, we want this size. Let's go pick up this much memory, this many CPU cores, and then Amazon had a way you could rent a mini, a small, medium, a large. And then they started getting crazy, like large with that's more about memory or storage, or before generic storage and stuff. And then people backed way out of that and said, or abstracted that and said, you know what, we don't really care about. We just want to do requests into compute and get answers. And we want a cluster. We want a Kubernetes cluster. We may reserve something, but we're going to pay for what we use. Like Amazon has this service called Lambda. And the idea of Lambda is you make a request. Now you build the thing that services the request, but it gets pushed in a generic way across as much compute infrastructure that you set up for it. And so no, you're not like owning the box, like, and then the other side of that was sort of like maybe that generation's extreme. And then there was the idea of building a cluster of these EC2 instances that were a logical cluster, okay, like a Kubernetes and the idea is that they'd spin up these little, what do they call them? Jeez, my brain is not as fried on this a bit, but containers, like Docker containers. They'd spin up these little containers that are like, they hosted on Linux, this little virtual universe, and your container could be running on the same machine and then you would have this cluster organizer like Kubernetes that would spin it off, and so it's routing the request to an available compute node. You're paying for it, but you stop worrying about under provisioning or over provisioning services. You stop that thought. That goes away, and you just say, I'll use as much as I need when I need it.
Paying for the grocery store to say, well, I want to buy corn, and the grocery store says, well, you've got to pay for a certain supply of corn, right? They don't do that, right? You just go in there and pay for what you actually need at that moment.
Yeah, but you certainly don't pay by the kernel. So,
no. Yeah.
So, you do pay by the ear. So,
yep.
It's just a matter of the granularity of the thing.
Yeah.
And yeah, the store could source, 3 different qualities of corn or types of corn, and that breaks it into these boxes, and some might be more cost, higher priced, and just like compute, something that would, one of these bigger boxes from Amazon cost more money because guess what? They're going to return your result quicker, or they can do more tasks for you.
Yep.
And I know, right now we're sort of, I think, largely in these frontier models. We're kind of like single vendor, and you pick a vendor and you work with the vendor, and you don't think of, even across Amazon, it's not as if that compute cluster just magically expands to Google or one of the other providers. It's still pretty much focused on, you're an Amazon guy, you're an Azure guy, a Microsoft Azure guy, you're a Google Cloud or whatever they call it, guy, and sometimes you can mix and match, but usually it's not homogenized, it's not standardized at a level that you can, it's like what Amazon does for Amazon Lambda is not something that is, I think, and I'm sure some people build some abstraction layers on top of that. Again, we talk about abstraction as like we can build a layer on top of all this that makes those specific services less specific, like we just homogenize the problem. So is intelligence routable this way? I don't know. Is there stuff baking out there that allows us to do this? I don't know.
So there's more to my article. We'll leave it here for now. If folks are interested, they can check out this article on my X account. But this idea of intelligence becoming a spot market and the financialization of intelligence, that's also interesting. We're thinking about, and then this idea of the real advantage is not just creating the most intelligent model, but then also effectively allocating it where it's needed, when it's needed, at the right cost. Obviously, that's a pretty obvious statement, I think, but something that'll become more important as time goes on. So let's completely shift gears. In fact, let's get off our planet and go to the moon. But Phil, I'm not sure that we've ever been there. Do you have anything to say about that?
Just go back one. Isn't that the most extraordinary picture, except for that iconic 1968 Apollo 8 picture that changed the world, was on the cover of every magazine, which I posted like a week before Artemis. This is the replacement picture, or at least the picture that's plus 50 something years. That's extraordinary, isn't it?
It's pretty cool.
By the way, you can tell that the Earth is flat from this picture. It's pretty clear.
Yeah, no, it's something about the lens warping the image. I don't know.
Yeah, something.
Yeah. Anyway, you had some fun with this.
I had a lot of fun.
Want to share a little bit about this journey you went on?
Yes. I stepped into it on purpose. People told me, "Oh, don't do this. You're entering crazy. You're entering a crazy place." But I did it on purpose. I just didn't know how many. I didn't know the crazy place was so big, and it wasn't this post. But it was this other post where I said, I'll give you 4 factual reasons why this is it. The moon landings happened. I mean, I was, and I started off telling the world that if you were one of these people that are highly moronic moon conspiracy theorists, I'm about to tell you that we did, in fact, go to the moon. And I gave 4 reasons. The first was that we brought back, 842 pounds of rocks.
Mm-hmm.
2, we put reflectors on the moon that we can ping every single day. And I think places on Earth do ping it. In fact, that's how we know that the moon is actually moving away from us every year. And then the third was, we've actually taken pictures from the LRO, the Lunar Reconnaissance Orbiter, in 2009 of the actual all 6 of the landing sites, right? And then I think the fourth one is I said something to the effect of like, this would be insane to organize a conspiracy of this magnitude. And I got a lot of responses, and the post went up to 300,000 views. And if you read through it, you will either agree with these people, in which case you probably aren't happy with this podcast or what we do here, or you think that somehow they'd win because they are very noisy and they have a lot to say, and I think they're crazy, and they've come up with like there's really kind of 2 categories here. I found. See, I didn't know much about the conspiracy side of this.
You found out the hard way.
I found out well, as I said, I stepped into it. I was ready to go. But I realized that the flat earthers are all moon deniers for sure, because if the Earth is flat, you obviously can't travel to the moon. The moon is just some kind of light source in a dome that was explained to me. I didn't know much about that, but apparently we live in some kind of flat. There's a dome and there's these light sources. One of them is the moon, and maybe the others are the stars. And those people, even though they're interacting with this and they may be going over satellite communications, they don't believe really in satellites either. So And then there's this specific category of people that are moon deniers. And I think like we haven't gone to the moon, humans haven't gone to the moon. They would agree that maybe robots have gone to the moon. In fact, that's how they think the reflectors got on the moon, autonomously through rovers that placed them. But and then that community, I think, subdivides into two. There's the rather unintelligent, feeling empowered, ignorant folks. And then there's another group that has more intelligent things to say. Like, I think both categories are a little crazy. And then I tried to, on my own, just trying to figure out, like, who are these people? Like, where are they coming from? Like, what's the motivation? And I think I learned all sorts of things that I didn't know. Like, most of them are fairly right wing. And then they accused me of being a Democrat because I guess this is like a science-based argument. I get a lot of them said that I was all in on vaxxing, if I believe this stuff, which I'm not really all in on, at least on not COVID vaxxing. But so it's very interesting how this whole community divides itself up. And I didn't realize how many of those people are on X. I thought we were just amongst a sea of rather intelligent people.
Well, humans have an amazing capacity to be tribal.
Yeah, it's that, and it's the psychology behind it. I mean, I don't know all of it, but it's a way of people feeling empowered even if they're not having the truth. They don't think of it that way. They think of I hold this piece of power. I can be a moon denier.
Yeah.
And then you're right. Then they group together in some tribal way, and we've seen the ugliness of tribalism in the last couple years on the generally in the political sphere. But this is just sort of interesting because as a kid, the moon was it was a thing. I didn't think of that for years as being. I don't know when I first heard that there was moon deniers, and but if you go back to on this 2 or 3, that one, I did this one for fun. I was like, okay, we planted 6 flags on the moon, which is true. One of the flags, the Apollo 11 one, fell over, and apparently Buzz Aldrin and Neil Armstrong decided not to say anything about it because it just sounded so terrible that as they left the moon, the thrust knocked it over.
Did it knock it over, and did it torch it as well, or just knock it over?
I think it just knocked it over. That they didn't. It was sort of apparently a last minute thought to pop a flag up, and so they didn't have the right. I don't think they knew much about they didn't know much about the terra firma of so that they didn't really know what they were and they brought this flag, and it was designed hastily, and I think they improved the design, and then somebody pointed out that they don't look like this at all. They've been deeply weathered. If they even look like this, they're all faded or something, but I did this on purpose because I was like, wow, I want to show that, not only are there 6, but they're all really close to each other. And
you just like to stir up trouble, don't you?
I do. I never thought of myself that way. I was talking to a friend about it. He said, well, this is the way you get impressions on X, is you create controversy. I'm like, yeah, I've heard that before. I've never really thought of myself like that. Like I didn't, very few posts in the past have I ever started is let's be controversial. Maybe the one about predicting robotaxi by the end of April would be a thing. But
you know what you've become? You've become just like the media who optimizes for clicks.
Yeah. I've never thought about optimizing for clicks, but it was fun.
Yeah,
but boy.
So related to the moon, I think in a very naive way that you launch a rocket off Earth and you go straight up to the moon. But as I've learned or reinforced what I really know, is that it's not a direct line. You've got a rendezvous. You've got a rendezvous with the moon at, with some precision.
Yeah, with a lot of precision.
Right. And it's pretty amazing, actually, too, how far away it is and how long it takes to get there. Even at high speed.
The basics are it takes a lot of energy to get off of the Earth, and it takes a lot of energy to accelerate. This thing was free running, so it really doesn't. Once it did its last burn, it left that Earth slingshot orbit at approximately 25,000 miles an hour, and then as it continued to run the 200,000 plus miles to the moon, it's effectively falling back to Earth. So by the time it got to the rounding of the moon, it was going at only less than 1,000 miles an hour. And on its return, it's now speeding up. And by the time it gets back on Friday night, this Friday, I think it's 5 p.m. Eastern, it will be back to about 25,000 miles per hour. And then we'll have to obviously slow to effectively zero when it hits the ocean off of San Diego. It's an incredible journey, really. I think that, I was all in on the journey. I'm just not all in on the NASA tech stack.
So is that what this is referring to?
Yeah, Artemis is fine, but I want my Starship. Yeah, go to the next one that I know you have here on the one more, maybe. Yeah, everyone should stare at this for an hour. It's cool. This is the thrust. I lined up Saturn V against the space shuttle against Artemis. Artemis 2, they call it Block 1, but essentially the configuration that we just saw launch against Starship. And so notable things is that the space shuttle and Artemis look the same because they are. In fact, I think call them SR-25 liquid fuel engines on Artemis are exactly space shuttle engines taken from space shuttle program. I mean, taken from like the Atlantis or whatever, the space shuttle. So, and then of course they reuse the solid booster concept. So they kind of retread that older technology. Saturn V, of course, was all liquid fuel, but not methane. So all the liquids here are not methane until you get to Starship. So Starship is, so I think everybody else is hydrogen, oxygen, and then Starship is methane and oxygen as the oxidizer. And just look at the thrust of Starship, the current Starship, that's the current Starship, I believe, V3. And compare it to, you pretty much can stack everybody up, and it's 20 versus it's crazy, right?
It's insane.
So I mean, I thought it was, it's an awesome mission, and I feel honored to be able to watch it and watch both of these in my lifetime. Actually, I mean, I was really a kid at 1968. I was 2 years old. Apollo 11, but the space shuttle was deeply part of my life, and I through both the Challenger disaster and then the I forget what the reentry orbiter disaster. Remember both of those very well.
Atlantis?
Was it Atlantis? I don't remember. The one that blew up on reentry. And the first one was the Challenger was because cold weather and the O-rings caused leakage in the solid rocket boosters, right? So they caused a flame throw out. And then the second one was because of the tiles. And, Elon is still challenged with these tiles on trying to build them on Starship to get reusability on the non-booster side of Starship.
Sorry, it was Challenger and Columbia.
Columbia, okay. Yeah. Very unfortunate situation, but it's a dangerous business. Look, it was incredible. I mean, those pictures coming back, absolutely stunning and incredible. And, I'm 100% in. I know we've been there, and I'm glad we're going back. And I wish some people would agree that we went there.
Well, yeah. So two last things related to Optimus. You had this post. Would you care to explain this to us all?
Yeah. So there is an electronic artist known as Gustavo Steen.
Easy for you to say.
Yeah. Pretty interesting guy. Pretty interesting music. Also a producer. Produced name blanking on the artist, the Italian lady from New Jersey.
Lady Gaga?
Lady Gaga, yeah. I think he produced her last album and was on stage with her at Coachella this year. But I just brought this up because something I like a lot, and just thought that the theoretical drop of Optimus V3 looked a little bit like Gustavo Steen.
There you go. Maybe they'll end up looking exactly the same.
People have asked, like, what's going on here with this thing? And I think that there is a non-literal way to take this and a sort of literal way to take this. And the non-literal is that they're essentially just saying to us, look, we're going to shroud this thing. We may put it in a fabric suit, but if we do that, it'll be for functional reasons to a certain extent, meaning like the actuators won't get caught in the joints of the, because those joints are exposed in the V2, 2.5, and so forth. But I think Elon is like saying, look, I want to shoot for the stars a bit on this one. I want to get it in the closest humanoid form that's reasonable for the time frame that I'm producing this product. And we know that there's a lot of energy being put into the hands, and that's going to make a big difference, I think. I think I've said this many times. I think when Optimus comes out, everyone will say, so what are those other robotics companies building? And the other thing I urge people to do is be patient. There's no reason. Guess what? Tesla's working on Optimus. Guess what? It's building a factory to build 10 million of these things on an annualized production basis as a starting point. So I think they're pretty serious about it. And I don't think we, as an audience, whether we're investors or not, need to really know, especially if we're investors. For investors, I don't think there's anything good to know what they're doing, because all they're doing is telling the competitors what they need to build.
Did Apple preview the iPhone before they showed it off to the world?
No. Yeah, I mean, very different cultures here. And I don't know what, I guess on a sort of maybe a more tactical, maybe called strategic basis, Elon puts this out early in cycle to build maybe market awareness and pre-acceptance of a product like this that would be radically different, as well as
attracting
team and capital.
Yeah.
Because in other words, people will say, oh, I see where this company's going. I need to be buying Tesla stock. I mean, if I didn't know about this product, I probably wouldn't have as much Tesla stock as I do today. Mm-hmm. So I can say that there's some great benefits to throwing it out there early. The other benefit is that, if you're a confident rabbit like Elon, you let your competitors make mistakes. You let them go through, like, I think his confidence is there's some really hard parts to this product, and the hardest is to manufacture it. I've written on this. I've already started my end part series on Optimus, and the first thing talks about like how hard it is to manufacture this product. I think Elon has a lot of confidence in the reality of that. And that includes not just the manufacturing of it, but the supply chain as well, right? To get to, the whole vertical integration that he attempts to do, whatever supply chain he needs to build, that's not, it's at the lower end of the pack here because of the vertical integration. and then building this thing in a factory at scale, he knows this is an extremely hard problem, and he thinks not only does he know it's a hard problem, but he knows it's a extremely capital intensive problem. And I mean, how many people can start erecting a factory to build 10 million of these things?
It's interesting when I think about this. A lot of people are very hung up on the idea that Tesla's behind. You need to be first. And in fact, I think, as you kind of alluded to here, that being first actually is not an advantage. You want to see your competition make the mistakes. You can learn from their mistakes without making them yourself. So it's not too bad to be a fast follower to some degree in certain things, because there were different design choices to make. Different robotics companies, I think, have explored some of those things.
Yep.
The other thing too is, by going public with this early on, he fostered a whole interest in this field. The robotics field existed before Elon threw his hat in the ring,
right?
But no one really cared about it. And now what you've had a lot of companies come to market. They've raised capital. They're these private companies, and certainly an explosion of companies in China. And that ultimately is good, both from a competitive standpoint, but also then in terms of building out that supply chain that you ultimately need. If it was just Tesla doing this,
I think it's a great
harder lift.
I think it's a great path if you're very confident.
Yeah.
If you're a confident kind of person, I think it's a great path for somebody like Elon Musk. Now, I think maybe Steve Jobs was also a confident person, but he had a different take. He would believe that he could imagine the product that would, because again, I think a lot of this comes down to is, while we've seen humanoid robots in lots of movies, we haven't had them in our homes. And while we may say the iPhone was revolutionary and all these things, look, even Steve Jobs said, look, it's an internet navigator, it's a phone, and what's the third thing? And it's a music player. Mm-hmm. All three things combined. Remember, he even presented it as these three ideas that people already could grasp those ideas. They already understood those ideas. In fact, when he was in his 2007 presentation, part of the funniness of that, or the whole point of it, was he was saying, hey, there's this product that does, Apple is building a new revolutionary to do music in this way, to do these other two things that we just said, and then all of a sudden, it's one product, right? I'm going to build a better phone. I'm going to build a better Internet Explorer, a navigator. I think he used the term, and I'm going to build a touch-based music player, and so people could already grasp those three objects, and even though we can grasp, how we can grasp this, because it's in human form. Yep. I mean, it's one of the reasons but at the same time, we don't have a relationship with these things operating in our homes. It's much more radical.
Yeah.
And the interesting question, I would ask you this question is, we've talked about this now for 2+ years in this community, and everybody would have you believe that these products start on the manufacturing floor and work their way into the consumer use cases. And Elon often says, who wouldn't want to have their own CP3O, R2D2? He just throws it as consumer. He barely. When's the last time Elon talked about Optimus in the manufacturing setting? I mean, I just don't know. I don't think he talks about it more as a consumer product. I wonder if it. I always said, no. Logically speaking, because of capability, Tesla's going to bring it to manufacturing first, and then into the service industry, the baristas type of thing, and the inventory counters, and the store shelf stockers, and then eventually bring it to the home, the consumer cases. I don't know. What do you think? Is that what's going to happen that way?
Well, I think so. When I look at it from a purely economic perspective, that's very clear, because even if the robot can only move boxes, that is still very valuable in a warehouse scenario, and it can work 3 or 4 shifts. If I have a robot at home that can just move boxes or things around, that's not that useful to me.
Right.
But in a warehouse setting, I'm willing to pay a lot for that because that's a very useful function. And then as the robot gains capabilities and skills,
that's it. Yeah.
Then it allows it to move into the home, but it has to be at a price point that people can afford.
Yeah, the tricky thing is that, and why what you're saying makes all the sense in the world, is you've got the economic grounding, but you've also got the capabilities kind of grounding, right? What you're saying is it fits the economics here, and it can be the least capable version of itself.
Yes.
And then it must gain more capabilities to find itself in the home. And it's hard to argue with that completely, because what we can say is one of the struggles that I've had with this product is to describe it, what it will look like on the first day it comes out and is available for purchase or lease, whatever they choose, beyond the walls of Tesla or SpaceX. In other words, it is in a customer's hands, whether that's a consumer or somebody on the manufacturing side or whatever. And what I mean by that is, definitionally, what is it capable of? What is its capability set? We know that we have like 2 components of this. We have the Vision AI stack that is about it being functional in the world, being able to manage a physical set of skills. And then we've got the reasoning, or my people might just say the LM side of the stack, which is about our ability to interact with it, to give it orders or get information that can affect its physicality, and the physical skill. But I mean, but if you think about it, there are some people who see this as a product that on day one, snap your fingers, it's like a replacement for a human. And then there's other people who see this kind of pathway to get there. There's multiple iterations of intelligence to physicality, skill, this physical stuff I call skills. And couple that with, does it have enough battery power to do these things? And I think, that's the divide where I don't know what the first gen will look like. And as Elon sort of moves up the stack, he's sort of telling us a story here, from version 1 to version 2 to version 2.5 to now this version 3. He's saying, well, I wasn't going to release version 1. That's substandard to my designs of what I want. I'm not going to do 2. I'm not doing 2.5. Looks cool. It's better, form factor. I'm doing this thing called 3. And we might find out that 3 isn't good enough, because we thought 2.5 was, I don't know what they called it at the time, but we thought 2.5 was the end of the road till it reached some idea of going into manufacturing. And now, we hear Elon saying, well, it's version 3, folks, and we will preview it. And that's the robot we really want.
Do you recall that slide on the Terafab presentation where they were showing the AI6 chip being used for Optimus? So that to me points to perhaps a greater need for more advanced silicon. And then the other thing that comes to mind is the conversations about reaching AGI, that we won't get there without the physical robot.
Right.
And in that case, you want to train it on the most variety possible in terms of data sets, and that's not just manufacturing or warehouse. That's in the home and everywhere else. So from a capability and financial perspective, I see it playing out the way I talked about. But if AGI is the goal, then it's a little bit different approach. And so the question is, how will Tesla approach this? If you wanted to get to revenue sooner, then you could, with low capability, you could throw it into a warehouse environment and start making money and deploy these things.
Right.
And there's some utility in that, and also from a training perspective, but perhaps limited.
Well, it's sort of, in a way, I think what's happened here is the exact same thing that's happened with FSD versions. It's the same process in my brain. It's what I just call the engineering process. And it comes down to, Elon Musk, walk into an Optimus review meeting, and I see where the team is, and I think about that as the released product into the world. And I ask myself, is that the first handshake with the world that I want from this product?
Yeah.
Pun intended. Is that the first handshake I want? It is the same conversation that happened with iPhone with Steve Jobs, right? Here he has this product. Was the first version, I think I have my little one right here. Yeah. Yeah. Here's the first iPhone, right? This little guy is a lot different than this current guy. And, do you think, obviously he didn't want to do this. This is the Palm Treo. It predated iPhone, but he might have wanted to do one of these. I think this is 3 or 5. I don't remember. I actually don't know. I think they're both the same, actually. But he did this, and this was good enough. But if you really look at it, there's a lot of there's certain smaller piece of glass here. It's thick relative to it's small. I mean, actually, kind of physically smaller than the current phones, but it doesn't have a lot of pixels on the screen. And is it good enough? And what you want is a product that's good enough that it doesn't feel so constrained that early adopters will take it up, such that the next version can come around in a near enough time such that that version can achieve escape velocity and become a massive product, right? And it's in that fabric of decision making that is so darn difficult, because
if you need the data, you release it sooner rather than later, kind of like FSD and having us all try it out and bring the data back. You can reduce the financial risk by saying, well, we're just going to rent this to you or lease it to you. And when the new one comes out, we'll just swap out the robot. Give us your old one back and we'll give you a new one.
Yeah, I mean, all those things. But then at the same time, he's not going to put out what he considers a substandard product. He wants to, in other words, he's put out, first off, from a data and training point of view, I've written on this, a lot of the stuff, while I think the compute side of Optimus far exceeds the compute requirement for FSD, okay? Far exceeds. Hence why we need an AI 5 and an AI 6.
Yeah.
And we have the other constraint, which is, while we have more compute demand, we have less power to give to compute. So a very difficult problem. But in terms of the data, the training, the pipeline, I think they've learned how to do that more in the lab with this product. And if you look at my first article on Optimus, I talk about how I think they're going to train this. And it's more about this ability to compose and decompose skills. And then the decompose is the probably interesting part, which means that you can get it to do some long chain of things, but within those chain of things, there's all these sub-skills. And in fact, it should be capable of decomposing those down to sub-skills. So making an omelet requires, sourcing the pan, the butter, the eggs, putting the pan, turning on the flame, cracking the eggs. But at the end of the day, that aggregation, that big skill, should be decomposable down to, well, I'm Optimus, I know how to crack an egg. I'm Optimus, I know how to get something out of the refrigerator, whether it's butter or milk, it doesn't matter at this point because I got the butter, So I think they've learned, and they have the infrastructure, and a lot of this, the vision stack of FSD effectively is a subset of what the vision stack of Optimus will be. And that's given them a great leg up because, if you go back, I think we talked about this previous show where we said, and I even mentioned it here, is that there was this, in the beginning of AI, as we know it, the modern AI, we've had this sort of war or, between language-based and vision-based AIs. And when Elon first sort of jumped in, his revelation was, from the ImageNet days and so forth, I can use a vision-based AI to build an autonomously operating vehicle. And boom, he's into that.
Yep.
Many, many years ago. And his foray into the language only happened really with OpenAI, right? And that's like, he didn't formalize that as a official Elon company or project within. Now, this product that we're staring at here, this Optimus product, is a combination of both of those things.
Yes.
And to be truly effective, it is the ultimate combination of those two things.
That's right.
So, we'll see. Well, I guess the point is, we will see where he throws it down and says, this is good enough to, good enough to go to market with. And, by the way, the other thing that we should, that's worth mentioning here is that one other rung in that, like, what is it? Is it capability? Is it what market do I enter? But with Elon, it's also manufacturability, right? And I say that because while you might say, well, duh, Phil, everybody thinks about manufacturability. No, they don't. I mean, they do and they don't. Elon, look at Cybercab. Cybercab, the building of Cybercab, the factory and the product are a product. It's like,
that's right.
And I think he's thinking of it the same way here. Is like, have we built these actuators good enough that we can manufacture them at scale and with a proper reliability, not just capability. Capability without scale and reliability is shit, right? It's like a very high priced thing that needs constant repair. Mm-hmm. If you're going to build a hand that can play a piano or thread a needle or do open heart surgery at some point, maybe that's not V3, maybe that's V3.5, V4. You better damn well be able to manufacture it at scale with great reliability. And so he's pulling all of that together. And I think we are here witness to the fact that he either going to get this right or he's not going to get it right.
You can always send them into space. It's the ultimate, playground, proving ground opportunity, I suppose, for Optimus.
And you know what? I mean, look at his post here. Off Earth will be vastly greater, and that's not a joke, because what he's saying is, if we want to colonize the moon and we want to colonize Mars, and then we can answer the why in a second. That's so economically, if you will, like grounded. It's ridiculous. Like it's like the story of even manufacturing in these environments. Ultimately, once we get past the issues of getting there and getting, but the story of manufacturing on the moon and drop shipping it to Earth is a story that can create vastly cheaper products. Mm-hmm. And especially if we're going to do it robotically, and the need would be like, we're not going to Mars without Optimus. Somewhere along the line, I did some post where I was talking about how much a starship could support in terms of a human life, transporting a human life, the 2+ year journey to get to Mars, and how much air you needed, how much space you needed, how much provisions you needed, sleeping quarters and waking quarters and exercising quarters and all these things where Optimus can be literally stacked maybe with their arms off in a corner, and when they get there, they're more capable than a human that needs more continuous life support.
And
now, mind you,
they get a software update as soon as they arrive, and they're more capable than when they left.
Yeah, well, totally true. Now, the realities of Optimus being put on the moon and Mars are difficult too, right? These products are not necessarily, they're thought, it's being thought of, but it's not. Would you say it's not a dimensional attribute of the current product to deal with the temperature variance on Mars or the moon dust or those types of things that will absolutely be definitional for the product's ability to operate there. So that said, there's a lot to do to make Optimus work on Mars, or the moon. But these creatures will be the most common creature in those environments by far.
One thing you'd probably want to do on the moon is to make it a lot heavier so that it doesn't, jump around as much like a human would.
Yeah, these are all things, beyond knowing the gravity realities of the moon, these are all things that are well beyond my pay grade in terms of understanding the nuance of material selection. And right now on Earth, it's like the struggle here for this product is it's a struggle that will present itself in a very big way to the Optimus team will be the power problem. And the power problem is compute over here and mass over here, and mass means just moving its extremities, moving the actuators to move its extremities, picking up stuff that is mass, and that you can do a straight computation people have of saying how much mass does the bot have. It has to have this perfect amount of mass for both stability but also power efficiency. And but that's not necessarily the front and center concern on Mars or the moon in particular.
Phil, we could go on and on, but if there's one thing that I heard you say today, is that you guarantee that robotaxi and cybercab is going to ramp up beyond supervised at the end of April. Is that the summary for this episode?
We're April 8th, man. I'm getting nervous. No, I'm willing to put it out there. If I think we'll get in spitting distance close, certainly. I think it's imminent now. Like, I don't think it was. People ask me, "Well, didn't you think of that in October? It'd be the same." And I said, "Yeah, to be a certain extent, I thought December was the date." So I'm fair, But I think one of the things that we've learned is that we should be sort of proud of Tesla and Elon for this, although it's hard to recognize that when you just want the thing, is that they are really, really taking safety seriously in this product. Every single day I can find a Waymo story where Waymo has done something completely stupid that Tesla would be boiled alive for if nothing else. And luckily, I don't think a Waymo has injured somebody in a serious way. I don't know, maybe that has, but we should be, as investors or enthusiasts, we should at least stop, take a pause, and realize that they are not effing up the safety part of this. Half of the community says that Elon is too optimistic, too aggressive, and too much of a risk taker. And then out of the same mouths of some of the same people say, well, where the hell is this product? Well, maybe it's because he doesn't want to put your mom's life in danger.
Yeah, I think Waymo, has a pretty good safety record. There's been a few incidences, but certainly there's a lot of inconveniences that Waymo has created for people, blocking the road and things like that. People being trapped inside the vehicles for a while. So, Tesla would prefer to avoid all that.
Yeah, we have to have a look at its safety and experience.
Yeah.
Recognize that the experience is, safety is important because we don't want to hurt somebody, or, either a customer or a non-customer, right? I mean, it doesn't really matter. But experience is important too, because that's affects the brand, and Waymo is, as you said, safety's fairly okay, but experience is, pretty poor, I think.
Yeah.
So.
Yep. Well, Phil, I appreciate it. Thank you very much. It's been a great discussion.
Thank you. Till next time.
We'll see you in 2 weeks.